So welcome to Building an Open Source Artificial Pancreas. Hopefully you're in the right room. By the way, I'm honored to be here because I've been to Strange Loop, I think 4 or 5 times now, but this is my first time speaking, so I'm really excited to be here. Yeah. And here it is. Here's the open source artificial pancreas. Thank you all for coming. Have a great day, and talk to you later. Okay. If you're like most of my friends, you've kind of heard that and thought, like, what the heck? What does that even mean? I expected it to be in you, not actually in a little cute pink pouch or something. So you probably have a bunch of questions, and I hope to answer all of those in this session. So, brief introduction. My name is Sarah Withee. I'm a software engineer based out of Pittsburgh. I do all sorts of things, different languages. I kind of like the variety to my life. I've been, in my past, a robot and hardware tinkerer. So I was on a robotics competition team in college. I've helped kids in robotics competitions win world championships, stuff like that. I've also done a variety of conference speaking, teach workshops, and different things like that. One thing I haven't really talked about that much in my life is that I'm a type 1 diabetic. And that's kind of one of the basis of this talk. But I think there's a lot of stigmas in our society, so I kept quiet for a long time. But this technology has been really so cool that I wanted to start sharing it. But before I can really talk about an artificial pancreas and what it does and the problems it solves, I think we need to talk a little bit about the science first. So to go a bit into carbohydrates, everybody heard of carbohydrates, I hope? Yeah. So when you eat carbohydrates, and that includes different forms of sugar, your body breaks it down into glucose and fructose. And for this talk, we don't care about fructose. We'll just kind of toss it in the imaginary trash can. That glucose then goes into our bloodstream. And from there, your pancreas will see that rise in glucose and say, hey, I need to make this insulin, which is a hormone. And it sort of this effect. So it sees it goes up, it starts to make more insulin. Once your cells see this insulin in there, that tells them, oh, hey, take this glucose and start using it as energy. So the central process is basically all of the cells in your body need glucose to work, but it can't use that glucose without this insulin in your bloodstream as well. And diabetes is just when this process doesn't work. That's it. I think people tend to equate it with fat people that like cookies, and while I do like cookies, that it's not necessarily what that process means. And you probably heard of the 2 types. So type 1 is, it's an autoimmune disease. So your body ends up attacking its own insulin-making cells. So you don't make insulin anymore. So this whole process doesn't work. You can't use those cells or use that glucose. Type 2 is where you still make the insulin, but your body just doesn't want to use it anymore. So for whatever reason, you can keep making it, it just kind of sits there, and your body's not responding to it. There's some other rarer types as well. You may have heard of gestational diabetes, which is where when you become pregnant, your body becomes resistant to that insulin. Sometimes it's temporary, so a month or 2 after you're done with the pregnancy, you can kind of go back where you were. Sometimes it's permanent. A friend of mine, back where I used to live, now has just type 1 diabetes because her body didn't recover from it. And then there's a few other types here. I won't really go into those. Technically, I don't have the autoimmune disease. I have one of these other types. My doctor and I aren't quite sure. We never ended up running some expensive tests to find out. So I'm actually one of these rarer types, but we just treat it like type 1, just like normal. So what we do to measure the glucose in our bloodstream, since it's kind of an important issue, in the US we use milligrams per deciliter. And in other countries, they use millimoles per liter. So I'm going to stick with the US system just for kind of a solid basis. So typical glucose ranges in your bloodstream, for normal people, as I like to call you civilians, they range from about 70 to 100 milligrams per deciliter. And after you eat meals, obviously some of your carbohydrates are processed, your blood's going to temporarily go up, but then it's going to come back down as your body processes that. Since diabetics have to manage this ourselves, doctors usually try to say, keep it in the 80 to 150 range, just to be a little safe. And after you eat, obviously it's going to go up. So it's like 80 to 180. So these numbers are important because bad things happen if they go too high or go too low. So if your glucose goes too high, you have what's called hyperglycemia. And that's basically where you start to have bad circulation problems. So little glucose molecules get clogged in your capillaries, the really, really tiny blood vessels. And so you start to have circulation problems that kind of compound over time. So it clogs your capillaries. Things like your eyes have lots of capillaries in them, so people's eyesight tends to go bad. Kidneys have a lot of these, so your kidneys start to function weird or possibly just not function at all. Fingers and toes have a lot of them, so that's why there's a lot of foot problems with people that are diabetics and things like this. So basically, slowly your organs start to fail. So we definitely don't want the sugar to go too high. If it goes too low, we have hypoglycemia. And so we have kind of this weird effect of people start shaking, sweating, they get really weak. I usually have to set for about 20 minutes because it just, like, I can't hardly stand up straight. I feel like I'm gonna fall over. So basically your body just starts freaking out. Like, oh my gosh, I don't have enough glucose to keep going. So you start kind of going crazy all over. If you've ever waited a really long time before you eat, or in between meals, something like 8, 10, 12 hours, you can start to have some of these effects as well. But diabetics can't really recover from this. So best case scenario, you have to just eat a bunch of sugar and you can recover in about 20 minutes. Worst case scenario, you can land in the hospital. Some have diabetic comas. If this happens in your sleep, some people have died from this. So this is not a thing to just shrug off lightly. It's really important. So this is why we have to kind of keep these glucose levels in order. Normal people often aren't told the warning signs until it's too late. I landed in the ER for something completely unrelated, and they said, we have to do surgery on you. We need to do a typical run-of-the-mill blood test. I'm like, okay. And they came back and like, your blood sugar's over 400. Like, I don't know what that means. They're like, you're diabetic. And they thought originally I was type 2. Eventually we found out I was type 1, and eventually found out like, oh, hey, you're this weird type over there. But the other thing is, once people are diagnosed, often they're told either too little information or just way too much. When I left, a diabetic educator had come to my room multiple times and left me pamphlets and booklets, and I probably left with literally 30 booklets. It was just drastic overkill. And I learned more from Wikipedia later. It just wasn't really worth it. So diabetes is kind of complicated. This is my prescription at the moment. Humalog is one of the brands of insulin. And basically, your usual prescriptions are take 2 pills twice a day, or take 1 pill at every meal, or something like that. I literally just have a blanket statement that's like, take some as you need it. Don't take more than 120. That's super vague, right? It's entirely up to me to figure out how much of this medicine I have to take. And so it gets a little complicated. So what is a unit of insulin? A unit of insulin is basically 1/100th of a milliliter. That's not super important. So it's just, we refer to units because it's just kind of easier. But everybody has a carb ratio. And that's for every amount of carbs that you eat, you have to have so much insulin to counteract it. And all of you have a carb ratio as well. You probably don't know it, but that's fine. Your body kind of takes care of that. But these range typically from like 3 grams to 1 unit to 50 grams per unit. So this range is really huge. And in the beginning, you just kind of have to take a wild guess. It's usually based on weight and body size and different things like that, but you kind of have to just fine tune it over time. So it's a whole lot of experimentation in the beginning. To make this even more complicated, these carb ratios vary. They vary from person to person. So if you look to your left and look to your right, you all have different carb ratios. It can change from different times of the day too. I need more insulin in the morning than I do in the evening. I have no clue why, I just do. It can change under different conditions. So like I just said, when I'm sleeping, I need a little less than I do in the morning. If I'm stressed, if I'm sick, all these different things can change this ratio. And this will change over my lifespan. My rate is different now than when it was when I was first diagnosed. So to make this even more complicated, because it's not complicated yet, when you eat carbs, it takes about 10 to 20 minutes before your body starts to absorb that and it goes into your bloodstream. And the insulin we have to take doesn't take effect immediately. It's kind of designed to slowly pick up the pace. So once you take it, there's about this 45-minute waiting period where it kind of like slowly ramps up, and then it just like hits you hardcore about this 45 to 60-minute range, but really takes effectively 5 hours for your body to absorb the whole thing. And this little chart here is kind of, it's a little weird to look at, but the blue line is the absorption rate. So it starts off slow, it picks up, and then it kind of tapers over time. And the purple area shows that reduction rate. So if you have a bunch of glucose, it slowly kind of picks up and then falls a lot quicker and then tapers off over that 5 hours. So to counteract the glucose levels, we have to take different doses of this medicine. We have two we typically refer to. So one's called a bolus, and that's I ate some food, I take the medicine for it. So I just had some pasta out there that has a bunch of carbs, I have to take the insulin for that. A basal is an all-day rate. So my liver is very kind, and it makes glucose for me all day long, but I still need the insulin for it. So I literally just have to have a stream of this medicine 24/7. Are you all overwhelmed yet? I see one head shaking, like, no, okay, let's make it more complicated. If you're stressed, your body will respond by raising your glucose a bit. If you're sick, your glucose will also rise a bit. If you're exercising or doing other physical activity really hard, that's going to make your glucose go down. If you have a little bit to drink, that'll go up. A lot of alcohol has carbs in it. If you drink too much, your glucose is going to go down because your blood composition changes a bit, so it has all these like side effects. And remember how I said hypoglycemia is like really terrible, you're weak and you're shaking, and I get like foggy-headed. You don't really want to be drunk and have all that going on. It's a really terrible combination. And then finally, if it's that special time of the month, right, ladies? It could go up, it could possibly go down, or possibly up or possibly down, or but anyway. So this kind of adds to the complication of it's not just a simple, give a dose, things magically work. There's always variables that are constantly changing. Is this all good so far? Okay, you're all like, yeah, I could totally do this. Okay, let's make it more complicated. If you're high, you have to bring it back down, right? You can't use a carb ratio to bring it back down. You need another ratio, and that's called an insulin sensitivity factor. And that's basically how much your body will use extra insulin to reduce its own values. So basically, however high you are of MGDLs above where you need to be, you need to take so much insulin to reduce it. This also varies per person, varies over time, et cetera, et cetera. So this is always a fun level. And my rate now is not the rate that I had in the beginning either. Cool. So we talked about exercise briefly. So this consumes glucose because you're using a lot of energy. Your cells need that extra fuel source. And your blood sugar will end up dropping fast if you don't account for this. So when I exercise, I have to take anywhere from half my normal rate of insulin to sometimes no insulin. And in fact, this is one of my bike rides I did a few weeks ago, where when I woke up, it was kind of about 90, 80 or so. I had 2 breakfast sandwiches. I had my bike on my car and I drove into McDonald's. It felt so weird to have a bike in McDonald's. Binging out on breakfast food, so it shot up. And then I biked it all off. It actually went all the way back down. I burned off all of those carbs and I took no medicine for it, which is something I have to factor into if I know I'm going to work a bunch. So kind of combined all together, all these things are just sort of scary. And it scares a lot of people, especially when they've been first diagnosed. They don't know how to manage all this because doctors are usually just like, I think you need, I don't know, for every 10 grams of carbs you eat, take a unit of insulin, here's your prescription, have a good day. And so it's a lot harder to manage, and I think we don't give people credit for this. And I'm really good at math and science, so all this makes sense to me, and I have trouble. So you can imagine people that just aren't really good at math, people that just don't get the concepts of all this, and they struggle with this thing. So hopefully we're at a technology conference and you all are thinking like, wait a minute, Sarah, like certainly technology can solve this problem. And sure, we have a couple main things of technology. Come on, slides, there we go. So there's two main technology pieces that can help with this. And the first one's called a continuous glucose monitor. And the second one is an insulin pump. And you've probably seen these on people before. A continuous glucose monitor, it's a little simple thing. I have one on my arm right here. You're welcome to come up and take a look at it later. So it's kind of stuck to my arm. There's a little sticker around the outside. And it has this really fine needle. It's like hair. It's really flexible. And it's just kind of like a little bit under my skin. Every 5 to 15 minutes, it measures my glucose level and then reports that over Bluetooth to my phone. So I actually have an app on my phone that says right now I'm about 102. Anybody remember if that's good or bad? Yeah, pretty good, yeah. So I'm 102 right now. So every 5 minutes, I get a little data point on my phone that tells me what things are going. And I even have a little thing on my home screen. I just turn on my phone and I can just see what my number is. An insulin pump is another thing that a lot of type 1 diabetics have, just because it delivers that stream of insulin. You can see mine sort of attached to me. I can't really pull it off. So it's trying to dose right now. That's cool. So all day long, it has my basal rates programmed into it. So it's giving me a little bit constantly throughout the day. I can also pull it out and punch a number into it. I don't know, 5 units of insulin, it'll just give it to me. So looks like a little pager. I pretty much have to have it connected to me. I take it off for showers. That's about it, really. The main problem is these two things don't talk to each other. They're two independent things, and I'm the one that has to look at my blood sugar and then determine what I'm going to do about it. And I just have to do this all day long. So that's kind of annoying. But also, we're still at a technology conference, and hopefully you all are thinking like, wait a minute, Sarah, certainly there's technology to fix this. And you're right. That's finally, it took 17 minutes to get there, but that's where the artificial pancreas comes in. Or as I like to say, taking my body to the 21st century. There's 3 main systems that are out there. And the first one's called OpenAPS, and that's the one I run. It's the Open Artificial Pancreas System. So it's a Linux-based IoT device. So this is actually a little chip on there. It runs Linux. It has all the memory and everything kind of on the same chip. It's also attached to a 900 megahertz transceiver board. So your phone doesn't communicate over that frequency, which is why you sort of need the extra device. And it's kind of weird that it needs a really old Medtronic pump. And Medtronic's just one of the brands that makes insulin pumps. And you need an old one because people found a security flaw in the radio frequency it uses. Normally, security flaws are a bad thing, but in this case, it's a good thing because that security flaw enables this type of system. And it's really kind of cool. And they found it and they fixed it in newer ones, which is why you need an old pump. LoopKit is the other really big major one. And it also needs a Bluetooth to 915 megahertz board. But this board kind of just doesn't do any of the calculations on it. It's just kind of a simple communication. So it gets a Bluetooth thing and sends the commands to a pump. It does everything on an iOS application. So you have to have an Apple device to do this. The unfortunate thing is it's not on the Apple Store. So you actually have to download the code. You have to compile it. You have to self-sign it and then upload it to your phone. So you can possibly see that people who aren't developers probably have not the foggiest idea what they're doing. And that's kind of one of the downsides of this particular system. We also have Android APS. So it's the artificial pancreas system, but it's built onto an Android app. So it kind of works similar to OpenAPS. They tweaked some of the algorithms a bit for their software, and I'll go into that a little bit later. But this one works with mostly European pumps. And while you could probably ship a pump over from overseas, all the supplies that you need are still over in Europe. So you'd be constantly having to ship stuff. And insurance companies don't really like that because you have American stuff. Why not just use the American things? So I can't really jump on board with this one. And then I said there were 3, there's this 4th one here. So this is a Medtronic 670. It is a commercial product. It's closed source, it's proprietary. Medtronic doesn't want you to know anything about how this thing works. But they try to make it as a one-size-fits-all system, which in a way I can kind of see that. But as you've hopefully seen for the first half of this talk, there's a lot of things going on. There's a lot of variables. You really kind of need a system designed for you. And as such, they have a lot of conservative algorithms. So they usually have just, we're keeping you as close to 150 as we can. Or if you're exercising, we're assuming you always want to, be at this level. Things like that. So we're kind of going to ignore that for the rest of our talk. So what the process happens is your little CGM, your continuous glucose monitor, gets your blood sugar value. So that's the top left corner. It passes those over to your phone. In this case, I run an open source app called XStrip. And it collects those blood sugar values from my glucose monitor. And then it sends those to a Heroku app called Night Scout. And Night Scout's also open source. So you deploy this to Heroku, and it just kind of runs in the background. They have an Azure version, but they're kind of phasing that out. So from there, your artificial pancreas system can download some of these values over different periods of time, spot the trends that are going on with you. So it looks at how much food you ate, it looks at your recent doses, and then sees if you're still going up or still going down. And then sends RF to your insulin pump to say, hey, have some more, or don't give you any more. So it essentially creates a feedback loop where there wasn't a feedback loop before. This sounds pretty wonderful. It is, but there's a few downsides. So like I said, it really needs some older pumps, the ones that have been reverse engineered or hacked, if you will. Since the pumps are usually that old, it means the warranty is worn out. So if the pump breaks, you're kind of out of luck. You either need to get a new pump and then you're off the system, or you have to go on eBay, Craigslist, whatever. I found some Facebook groups as well to sell some of these old pumps, and you can buy them from them. But because now these old pumps, which didn't used to be worth much, are now like worth a lot more, they're starting to become more and more expensive. So it's sort of a weird, like retro thing where, like records are coming back. It's kind of like old insulin pumps are coming back. And newer pumps aren't compatible. Med companies are still like, no, we're not going to work with you because you're not FDA approved and blah, blah, blah. There is an organization called Tidepool, and Tidepool's trying to become the sort of middleman between the FDA and the tech companies that are closed source and be like, we don't want to work with you. And the open source companies that are open source people that have said, we have good algorithms. These are tried, these are true, these are tested. They work. And so Tidepool is trying to be that first middleman corporation to say, we want to work with both of you. It also improves the situation a lot, but it's not perfect. A couple days ago, I ended up having a bad hypoglycemia. I had ended up overdosing. And the problem is you can't take your insulin back once it's in you. So you either have to just eat more or bad things happen. So it tried to rescue me. It cut off all my basals and just said, like, you're not getting any more insulin. And it, reduced my curve, but it didn't, stop it. So I ended up going hypoglycemic anyway. There's no support from medical companies. I know a lot of doctors are very much, well, I've never used this system. I don't know what it is. You need to stick with the newer stuff that, companies have made and tested. My doctor was just kind of like, she was doing some blood tests and like, your sugars are really good. What are you doing? Finally, I ended up telling her, and she was like, I kind of vaguely heard about this, but if it works for you, great, keep doing it, because that's what's most important in the end. And kind of like I said, med tech companies, they pretty much hate this thing, partly because they can't control it and make money, I think. There's probably more politics. In fact, they hate it so much that the same security flaw tends to keep coming up. It's been out for like 8 years or something. But this is from earlier this year. This is the big, oh no, bad warning, cyber hackers can get into your pump and blah, blah, blah. Which then also spins off the FDA. It's just like, oh my God, bad things are happening. You all are going to die or something. I don't know. But it's basically the same security flaw constantly. And everybody in the type 1 community that's running one of these insulin pump or artificial pancreas systems like, hey, by the way, this is a good security flaw, if there's such a thing. Yeah, so it's kind of one of the downsides is we sort of have to play this politics game. There's a few different algorithms. I'm not going to dive too much into these, but ORF0 was the original one. There's white papers on it. If you're really curious, you can go out and read these things. So basically, it just adjusts your basal all day long. So if it starts to see you going high when you shouldn't be, it can bring you back down. If you're going low when you shouldn't be, it can kind of bring you back up. So it makes really fine-tuned adjustments there. ORF1 is a newer version of the algorithm where it adjusts that and then gives you extra little insulin shots, if you will. I think of it like little espresso shots to kind of like try and bring you back down. The loop ones are kind of similar, only they offer extra recommendations. If you say, I ate this much, it's going to think like, I think you need to take this much. And then from there, you can kind of enact on it. Android APS is basically the ORF0, but they add some time adjustments to it. So you can kind of adjust how much time it looks back to make these adjustments. Okay, so I talked for a really long time. Who's ready for a live demo? Ooh, all right. We're going to switch to mirroring real quick. Boop. Cool. Yay, it works. All right, ta-da. Here's my body in real time. How exciting is that? Okay. Earlier I was 102, so you can see I'm 103 now, so I went up just a tiny little bit. Sometimes in conferences, there's a little bit of signal interferences, so my last value up in the left corner, you can absolutely see it said 10 minutes ago, so it actually didn't get one 5 minutes ago. So hopefully that'll pick back up in a minute. All those points in the middle, the greens and the yellows, those are all the data points over the last few hours. And then at the bottom, you can see over a longer period of time. Oh, it looks like I went low in the middle of the night. That's weird. But yeah, this is over like 36 hours. So you can kind of see like I'm fairly green for most of it, which is pretty good. Up at the top, I have all this status information. So on the right side, under the 103, you can see the +1 means since the last reading, I went up a value. IOB means insulin on board, so right now I have 7.3 units kind of floating in my body. That hasn't been absorbed yet. Some of the other things in the next row are kind of ages of different things. So how old my insulin is, how old the tubing is, when the last time I stuck a sensor on, different things like that, so I can kind of keep making sure I don't leave them on too long. And then over on the left, oh, my phone's 7% right now. That's not good. But I can read all the status information about my pump, too. So I have 290 units stored in it, so it's good for a long time. My battery's 1.37 volts, so it's starting to get low, but not quite there. Different things like that. And then over here, there's an open APS one. So I can hover over that and actually see how it's calculating the different things. It's too small, I can't really zoom in on it. But it shows like all the different data points it's looking at, and then its final prediction, which at the moment just says to adjust my basal a little bit. And then the dots in the middle are also, I took 18 units earlier and then ate 61 grams of carbs at lunch. So those two are supposed to kind of counteract each other. And then over here on the left, you can kind of see a 0.2, 0.2, 0.1, 0.1. Those are those microboluses. So that's the pancreas telling the insulin pump, give me those little tiny things. It thought I was going high, so it was trying to bring me back down. And then over the big blue ranges, it might be hard to see, but there's a little dotted line. Those are my default values for my basals. So the actual blue shaded part is its adjustments. So there's a couple parts where it gave me a little bit more. There's a couple parts where it cut me off. Different things like that. So you can see those. And then finally, there's all those colored dots off to the side. Some of those are, this is your trend of carbs, which is going to keep going. Your trend of insulin, which is going to go down. And then the ones in the middle are different calculations for where it thinks it's going to go. So ultimately, it takes an average of all of those to figure out what's going on in my body. So this is me. This is live. I'm going to stick that over there real quick, and then pull up a terminal. I'm going to plug in my pancreas, because that's what one does, right? Cool. Its name is Sarborg. Sarah Cyborg, yeah, anyway. It's gonna mess up real quick. I don't know why it always does this. There we go, cool. So L is the simple command that basically prints out the logs. So at the moment, you can actually see literally in real time what it's doing. So since you only get a new sugar value every 4 minutes, it doesn't run constantly. It only runs once every 5 minutes to update things. So right now it's been looking for interferences. It's not seeing any of that. So it's doing kind of initial communications between my pump. Come on, do something fun real quick. Running out of time. Yeah, there we go. So it also checks the time on the pump to make sure it's within, I think, 90 seconds, just to make sure it has all the correct doses whenever I'm manually issuing them. It downloads everything I've done to the pump, so if I gave myself a dose, it downloads that so it can record it into Night Scout. Come on, do something fun. Okay, so there, it's refreshing the pump history. It should kind of scroll up a bunch of stuff here. Yeah, so now it's refreshing my temporary basal. So it's sending a command that says this is your new basal rate now. And a bunch of numbers are going to scroll up. There we go. And those are all the kind of statistics it's doing. So it's downloading all those different values, running the analytics, figuring out what's going on. And then no bolus needed. So it says you're fine. I think you don't need any extra for all of the food you've eaten. So yeah, so that's basically, it just completed that loop. And now it's going to go to sleep for a few minutes. So kind of nice. One of the things it also does at 4 in the morning every day, and I'm going to run a version of this locally just because it's faster. This is called auto-tune. So it looks at those basal rates that I programmed into my phone, looks at every hour of the day and sees, okay, you have this much insulin, you ate this many carbs. What's the difference? And if you're higher than it expects, it's going to raise your basal rate. If it's lower than it expects, it's going to lower it. But the other thing it can do is adjust the carb ratio. So that's the ratio I had programmed in, that's the new one. And changes my insulin sensitivity factor. So milligrams per deciliter per unit, so it's adjusting that. So they're pretty on par. There's a couple like hourly ones that are a little bit off. But every night it runs this and kind of updates me. And I can run it locally too in case I want to change anything. So that's pretty cool, right? And then finally, I can come in here to reports. And let's say I want to run a report for like the last couple weeks or something. I'm just going to run 3 days. But it will quickly, boop, there we go, do these reports. I can take a look at data over time, see what's changed, how many carbs I had, and how much insulin was given to me. I can print this out and give it to my doctor. I could even give my doctor access to this website. I can give friends or family access to this website too, so they can kind of keep track of me. So lots of cool things about this system. So I'm running out of time. We're gonna kind of go back where I was. And for some reason, Linux always puts my slides on the wrong monitor when I go back. There we go. Because I run Linux on my Pancreas, why not run Linux on my desktop? They're not related. I know I'm running low on time, so we'll try and breeze through this really quickly. Lots of people tend to ask a lot of the same questions. So is it really a pancreas if it's not inside of you? I mean, no, it's not technically a pancreas. It's an open looping hybrid device. It's called an artificial pancreas just because it replicates a lot of those functions that you sort of do normally. So it's just kind of easier to say artificial pancreas than an open looping hybrid device or something. So wait, this is on the internet. and it's giving you medicine, can you really trust it? And for the most part, I can. Like I said, there's a lot of research into it. There's white papers. I've looked over these. The algorithms make sense. I kind of ran it through a trial mode where it offered the suggestions but didn't take action, because you can enter in safety limits into it. And all of the suggestions it was making, if I tried them, they worked. And they were working better than my own suggestions. So I'm like, I think I can truly trust this thing. If it's online, can't you hack it? Sure. I mean, we can kind of hack anything that's on the internet, because you have to go through my phone because it's tethered to the Wi-Fi, and then get into the device, and the device has Linux, so you kind of have to break into Linux, and then you would have to like run scripts to, I don't know, dose me a bunch of medicine if you didn't like me. Or possibly break into Night Scout and make adjustments to different things. I don't know. I think the level of complexity to do this is annoying. But if still you wanted to do that, the insulin pump doses really slowly over time. So I would start to hear it beep, because it beeps every time it starts to make a new action. And if I didn't hear it, my phone would start dinging and be like, hey, you know, you're going low and you shouldn't be, you need to rescue yourself. So typically I would just see bad things are happening and like, that's weird, and kind of move on from there. Is it annoying to carry everything around? And it is a little bit. So besides that, I have also, I call this Sarah's diabetic stuff. It's just a whole bag of everything I have to carry with me. And these are all like the finger pricking stuff. Yeah, you get a bag. So I carry that all around with me. I'm waiting for TSA to stop me at some point. Like, why do you have a giant bag of needles in your backpack? I'm like, well, but I like to think my health is better because of all this, and it's kind of worth a little bit of annoyance. What if the battery dies? Because of course, your pancreas can die. I have to charge it, but because it doesn't do that feedback loop, I just kind of go back to manual mode. And same thing if I lose internet access, because it can't download those values, it can't run the trends, sort of the same thing. I just kind of go back to manual mode. So same thing when I'm on an airplane, I kind of lose that internet access for a bit, so I just kind of deal with it myself. Why is it not FDA approved? It's kind of complicated. There's a lot of mess behind it. Essentially, this is a self-experiment on yourself. It's an experiment of one. So because the FDA doesn't regulate those, you can kind of do this on your own. They don't really care. It's also not a sold device. You can't buy an artificial pancreas. So you buy the parts to build it, and then you build it, and then you install it yourself, and you kind of do all the configuration. So they don't regulate that. So why have the med tech companies not done this? We kind of talked about the Medtronic, which is kind of Everybody I hear that uses it usually turns off the looping part just because it's not that great. The sensors aren't very good. There's a couple that are still trying to do it. Basically, it's just expensive to do all the research into this. They already have pumps that work. Why do they need to make a fancier system? And then there's some other politics I won't get into. But basically, before I had this, I struggled to keep really good blood sugars. They were high a lot. It was very easy to go over 200. I just sort of struggled to keep up with this. Afterward, you can kind of see, after I turned on the first algorithms, I have a lot of grain. These values are really good. And you can kind of see at the bottom, all these blues, that's adjusting all those basal rates for me. You can just see in general, there's a lot of activity. But once I turned on the newer algorithm, this is 6 days of entirely green, pretty much. There's a few little tiny red spots. 6 days worth. So much activity going on here. And this is like whether I didn't eat anything or I just like binged an entire pizza kind of stuff. Like it took care of me either way. And it's kind of amazing to have this. I also love that I can go to bed and wake up and I'm pretty much at like reset every day, even if I took bad care of myself the night before. So kind of zooming in on one of these, this is a literal 24-hour period where I just had like amazing blood sugars the whole time. In fact, at a previous conference, I had a type 1 person come up and ask a bunch of questions. I met his wife at a party later, and she was like, I'm mad at Sarah because she has such good blood sugars, and I can't do that myself. Yeah, and it's amazing that I don't have to do anywhere near as much work as I used to. So trying to wrap this up, the code for OpenAPS, the instructions are at read the docs. You can go to the GitHub repo and get OpenAPS. The backend, which is Night Scout. XDrip is the Android app that you can use to collect the blood sugars. If you're running LoopKit, which is the iOS-only one, the instructions are at github.io. You can also download LoopKit. Riley Link is that hardware board. It's open source, but unless you have like a hardware building laboratory in your basement, you're probably going to just prefer to buy their pre-made one. And they pretty much do it, just you're paying for the parts. They kind of assemble them for free. I want to leave you with kind of how the system can better people in ways you might not think. So young children that are diagnosed with this are terrible at managing themselves. Their parents usually have to interject. What if they could just run around at recess and just hold one of these little devices and it just kind of took care of things themselves? And the nurses can kind of watch remotely over the internet to see how the kids are doing. They don't have to come in on a regular basis and check the kid's blood sugar. What if older people that aren't really good at managing their own medicines or everything could have a system that did it for them? What if those caretakers of the older people could get those notifications and know if something's going wrong? What if low-income people could use some of these older devices that are cheaper and get better care from it? Or those without health insurance either, that can't afford to buy a brand new $12,000 insulin pump. They could, yeah. That's right. They're expensive. It's ridiculous, and our industry is kind of terrible about that. I wanted to give back. I've subscribed to these GitHub repos, like, I'm gonna make commits, and they're super active. They're constantly being updated. I don't have to do a darn thing. But I realized taking devices, flashing them with operating systems, dealing with Linux, Git cloning, whatever the heck that means, installing bash scripts, whatever the heck that means. These are things that non-technical people don't know how to do. And so this is a really intimidating system. What if these could be automated? What if you could plug it in, it detects the type of device you have, and then it could kind of install itself from there. So that's what I've started working on. Unfortunately, I don't have anything to show for it. And finally, I want to leave with you one last point. What if our software had a greater purpose? What if it wasn't just about delivering better ads, but what if we could solve problems that even major corporations didn't want to tackle? I just think it's an amazing thing that we should all kind of keep in the back of our mind as we continue to work. Thank you all for coming. Thank you for dealing with this slightly longer.